Hi. Yeah, thanks. My name is Robert Mosolgo, and I'm going to talk to you about GraphQL. I wanted to introduce myself by telling you about my recent hobby that Val just mentioned. Let's see. My recent hobby is sewing. And it's kind of an unusual hobby for a programmer, but it's really growing on me. This is the machine that I'm working with these days, and I love it's so mechanical. You see the different buttons and sliders, and when you push it and move it, you can hear all the gears kind of clicking into place. And when you run the machine, you can smell it running. You can feel how it pulls the fabric through. So these are some of my projects you can see above the window and the curtains and the little bench. And the curtains were hard because you have to line up the pattern, so you can't see the seam and you have to keep it all lined up. And it's kind of like looking at an old programming language, or if you ever read about assembler, some people are into that. That's the way I feel about sewing equipment. So here's an attachment called a ruffler, and it's for making ruffles when you have the fabric is folded and sewn like that, folded and sewn. And it's just, here's a little example. Like, this thing is amazing. It just goes up and down, and somehow it makes this, who thought of that? I mean, it's great. Here's a spoiler. It has these teeth in the back, so every time the needle goes up and down, it increments the wheel, and on the deeper teeth, that's when the ruffler arm pushes its fabric through. And you have to oil it for it to keep working. I use a laptop that I never have to oil. It's just fun. This is another cool project. I didn't finish it, but I like interacting with the history of different sewing projects too. So this chair I got from Craigslist. Someone they had got a new one and was trying to give this one away. And the fabric on it, it's hideous. It's terrible. And you can't tell that it smelled bad. So I thought, I'm going to take everything off and put it back together. So far, I've taken everything off, and I've now put it back together. But I love digging in. So here's peeling back the arm. You pull the fabric, and the fabric looks, well, it's actually kind of new. I don't know why it smells so bad. And underneath was polyester, kind of plastic padding. And then there was cotton, and under the cotton was wool. And under the wool is this crazy brown stuff. Well, I had no idea what it was. It was crumbly, and I learned that it was hair. That they used to upholster chairs with horse hair or pig hair because it was really springy, and it lasts for 50 years or 70 years. But this was falling apart, it was dirty. So maybe it's 100 years old, I don't know. Yesterday I was walking around the city center where you can see the different churches and the Turkish mosque, and below that there's the Serdica roads and walls and all these ruins. Where I live, we don't have Roman ruins, but we do have 100-year-old hair. Just have to take apart furniture to find it. So I really like the personal aspect too. The machine that I'm trying to use is my grandmother's machine. I used to call her Mama. That's me and Mama when I was a baby. And she's dead now, so I'm not learning to sew from her. I'm learning from YouTube, which is a shame. I missed an opportunity there. But it's fun to share the same machine that she used to use. So that's enough to introduce myself and talk about sewing. But I was told that we can have questions after the talk. If you want to talk more about it, let's talk about GraphQL. So maybe you heard I'm the maintainer of GraphQL Ruby, and so this talk is about design mistakes in GraphQL Ruby. First, I'm going to introduce the GraphQL system, the language, and then I'm going to describe my learning experience trying to build it in Ruby. And I hope it will be like, have you ever seen those pictures of the Titanic where it's starting this big ship that's sinking in the ocean? It will be a warning, so we can learn something from it. The first step is to say, well, let's talk about what is GraphQL. It's an API system, so it comes in handy when you have a client who's visiting your website or using your mobile app, and they need some data from your server. That's your Rails monolith. And GraphQL fits in two places. First, when the client requests some data, the request comes in the GraphQL language, query language, that's the QL. Second, when the server executes that query and sends a response, that's called the GraphQL runtime, and it returns a response to the client. So we're going to look at those two different parts to get a sense of what is GraphQL. The first part is the query language. So here's a GraphQL query, and I'm going to describe it just in plain words. So this one, what it's going to do is ask for the first 5 users, and then for each of those users, we're going to get their login, their username, and for each of those users, we're going to get their first 5 repositories and ask the name of that repository. So from a language point of view, how can we describe this? The first thing we have is a selection. If you ever think of a select statement in SQL, these curly braces say, this is the data that I want in here. Oh, there's some light gray, but it doesn't show, sorry. Then we have the fields. So fields are when you request data. This is the actual data that you want. You use fields to name them. It's kind of like selecting certain columns from a database. Some fields have arguments that you see the key value pairs there. That's how you can do things like filtering and sorting and it's so bad, it doesn't show. Then if the field returns an object, you can select more things. So when you get a user, for example, you can select the different fields from each user. There's another field. This one doesn't have any selections because it returns a string. It's a leaf field. It returns a scalar. Here's another example with everything all together again. You can see the field and arguments and a nested selection and another field. That's a good overview of the language. So what about the runtime? Here's another example query. We're going to search for a repository by name. I'm a big Redis fan, so I got to use this as an example. And when we find it, we're going to ask for its name again, and then ask what languages is this repository using, like what is the name of each of those languages. So from a runtime perspective, how are we going to execute this? Here's how GraphQL works. The first thing we do is we take that main selection and we start building a JSON response. Everything is going to go inside the data key. Next, we visit the first field, repository, and since the field is called repository, we make a key called repository. But what's going to go there? That's when it gets interesting. So, we have a repository field with the name, and we need to get some object. This is where GraphQL interacts with your application. Every field has something called a resolve function, or a resolver. It's some code in your app that should get executed for that field. Here's an example. I don't know what it does, but it's some method that gets called and returns a repository. Since it returned a repository, we're going to put another object in the response. The object was empty, so what goes in there? We're going to go to the next field, call another resolver, and then put the string in the body. We're going to do the same thing on down the line. We did call the languages, and for each one we got its name. So I think that is a good example of how the runtime works. We go to each field, we call some kind of resolve function, and we put the result in this hash. You can see that the hash we end up with, it actually matches the query structure. So each field that's in the query is present in the response. That's a good overview of the runtime. You might have one more question. You may have many more questions, but I'm only going to answer one, which is how do you know what fields you can request? I mean, it's just calling code like crazy. The answer is that GraphQL also has a type system called a schema. And a schema is full of different types that map to your application code. So the ones we were looking at is a repository type that has, we may have more than 2, but here are 2 example fields. Name, which returns a string. You see the bang, that means that it always returns a string, it never returns null. Languages, that returns a list of languages, and then language also has a name. There's another type by convention called query. That's the starting place. So, for example, the query type allows us to look up a repository by name. And besides that, there are input types. So, if you take user input in GraphQL, it's like controller parameters, but a little bit different. Everything is type checked and validated, so you can be sure that it's a good input. And that type system is the basis of a lot of GraphQL tooling. So we have a special editor called Graphical that you can see here. It's connecting with the GraphQL backend, and that backend publishes its schema, the type system, and you can use that as you're building the query to learn about the system. If you make a mistake, it knows that you made a mistake. It's something we don't get with Ruby very much. Or maybe we get it after it's too late. And it has built-in documentation, so if you have a question, or you can open the docs button there on the side, and you can see all the different fields for repository in this case. If you want to experiment with GraphQL a little bit, GitHub has an example that you can visit and poke around and see your data on github.com. So that's it for my introduction of GraphQL. It's a very small introduction, but we talked about the query language, the runtime, how those queries get executed and turned into a response. And we talked about the type system and the kind of tool you can build on top. If you want to know more about the idea of GraphQL, it has a specification. It was created by Facebook a few years ago, and now it's open source. It's very formal looking, and it has some really academic looking pseudocode, but it's actually very readable, so if you like that kind of thing, I would really recommend it. And if you want to put GraphQL in your app, here's a talk from RailsConf this year that I really recommend, the GraphQL way. A lot of good questions are answered there. Right, but I was going to talk about design mistakes. Well, you have to imagine me 3 years ago. I'm at ReactConf at Facebook headquarters. I'm younger, I had a little bit more hair then, and there's just a great presentation about GraphQL. I thought everyone would like to learn GraphQL. They would like to learn the ins and outs of the language. They would like to learn the details of the runtime. And after they do all of this learning for fun, then they could build a system with Ruby. So I'm calling it GraphQL flavored Ruby, where all the ideas from GraphQL get kind of shoved into Ruby API. What does that mean? We're going to look at a few examples. One, I mentioned there's something called a resolve function. Whenever you request a field, you execute some code in your app. So my first approach at that was, hey, why not use functions? Ruby has anonymous functions called Procs. In fact, we almost never use them. Here's how you can define a field in GraphQL until 6 months ago. Do you see the proc? We never use them, but that's it. Oops. It has a little stabby arrow like this and takes some arguments and then calls the code there. I thought, oh, that's fun. We never use these, but maybe we can do some functional programming in Ruby. It turns out there's good reasons not to use them. The first is that we don't use them. And so whenever you have to debug it, it's very unfamiliar. For example, self, like what is self inside that block? Any random thing. When you get a stack trace, because it's an anonymous function, you don't get a name. Like if you call method, you get method names in your backtrace. And actually they're a little bit slow. It's slower to call a proc than it is to call a method, and that kind of stuff adds up. And finally, it's just hard to work with. If you need to extend a method, we know all the different kinds of tricks for that. But what about functions? There's something called functional composition, but we don't do it very often, and Ruby doesn't support it very well. So it took me 2 years to learn that. In fact, there are all kinds of procs in GraphQL Ruby. If you've ever used it, maybe you recognize that or have flashbacks. Sorry. Another issue that I learned was really just a bad design on my part. So the GraphQL spec described how to execute a query in great detail. Instruction number 1, instruction number 2, instruction number 3. And I just opened my editor and started writing those things in Ruby, basically as a giant method, one giant method. And it worked. It took some inputs, the schema and the query, and it did lots of stuff, and it gave you a hash. But we're Ruby hackers. Like, we want to experiment. We have some deadline that we need to meet with this special requirement. And when you have one giant method, it's like a black box that you really can't hack into. That's too bad. I have one more big mistake. In GraphQL, they always use camel case, and I put camel case in the Ruby code. You think it's not a big deal, but one day after another, it really weighs down on you. So it makes me tired. In the end, I learned that GraphQL flavored Ruby was not productive. You know, Ruby, the thing that we love about Ruby is that we can get a lot done in a short time, but when you force people out of when we don't use the kind of paradigms that we're used to, it just makes us angry. So a year ago, I started working at GitHub, where I joined the API management team, and they do a lot of different things along with that team. And one of them is to try to help us be more productive in building our GraphQL API. And fortunately, there are a lot of folks there who, they had been using it a lot more than I had. GitHub made a big investment in GraphQL, and they're really leading the way there in a lot of ways. And people had thought about the different things that were slowing them down, what they wish it would be. And so our team gathered these different requests and complaints, and we thought, what if we turned the library on its head? What if we took Ruby paradigms first and figured out how can we take Ruby paradigms and make a GraphQL system? So what kind of things, what are those Ruby paradigms? The first one is inheritance. So everything is an object, and the class hierarchies in Ruby are tremendous, and that's really a good way to share code and extend things, whether you're including modules or extending modules, or prepending modules, or refining modules. Just kidding, nobody uses refinements. So maybe we could use classes to build our different types. I think that makes sense. So here's the user type. It's extending some kind of built-in base class. If we want to add fields, we can do that in the class definition, and fields get inherited just like methods. And what about those resolve functions? Well, we could use methods for that. This really clarifies how the code works. It's something we can extend using super methods, and importantly, when you get an error, you get a proper name in the backtrace. So we've been using that for a few months now, and it's a big sigh of relief. Another thing that I've been learning about is, as Ruby developers, what do we expect from our object state? You know, if you think about a controller or a model, these are things that they get instantiated, and we do a few things with them, and then we're done with them, and they go away. They're short-lived objects. But in the first round of GraphQL, I really didn't think about that at all. And so many of the objects that were used, when your Rails app booted, it would create some object, and the object would stay around forever. And if you weren't careful, it was easy to get out of sync as the application was running. So sometimes we do stuff like this, right? You have some expensive call out to your Git backend. You want to memoize that result so you don't have to make the expensive call next time. We should make it so this just works, and it does now, which is nice. So this is a lot more familiar, and it reduces the risk of shooting yourself in the foot. Finally, so the things I just described, if you go download GraphQL now, you can do them. I have one more hope that I hope will be done this summer. So I mentioned that the GraphQL runtime is described in the spec, and you can have that really standard behavior if you download the Ruby gem. But there's always reasons to change the spec. People are experimenting with interesting things like, what if instead of sending the hash all at once, we're going to send it piece by piece, and you can send it down a WebSocket or a long response. There's all kinds of different ways. We want to, at GitHub, we're big users of feature flags, so we develop features over a long time, but they're not enabled for everyone. And what if we could build that into the runtime so that GraphQL can respect those feature flags? So I call it hackability. If somebody has a better word for that, I would love to know. I think, what if we did some OOP here, right? In object-oriented programming, you have two things together. You have some data, like the attributes of an object, and you have the methods, the behavior of that object. So what if we could put execution right alongside the type definition? And that way you could do interesting stuff, like if you want to measure how long execution takes, you can wrap the super method with your timing, and then record your metrics. I think that would be really nice. If you've ever used GraphQL and you try to do this stuff, you know that it's not easy. So if you're interested in this kind of thing, there's an open pull request that you can keep track of. It's on our team's to-do list because we need a lot of different stuff like this. I hope we'll be done this summer. Finally, there's one more important lesson that I learned. We should just use underscores. So in the new version, if you download it, you can write the way that Ruby was meant to be written, and it will make you feel a lot happier. So just to summarize, something that I've been learning is whatever I want to build, I should think about how to take Ruby workflows and paradigms and apply them. So in my case, that meant, how can we use inheritance as the way to build this system? Think about the state of the different objects that you're encouraging people to use and try to make them short-lived. The short-lived objects, they add up, they can be expensive, but in general, they're just safer to use. And finally, how are Ruby hackers going to extend your system? We're going to do that, and so it's better to make it easier. Oh, actually, there's one more thing. Yeah, always use underscores. Don't use camel case. So, a lot of this stuff you can find on the new version of GraphQL Ruby 1.8. The documentation is not as updated as the source code yet, but you can find some things on the website. And yeah, for the hacking execution, I hope you can find it this summer. That's it for my talk. If you have questions, I'll be here all day and tomorrow too, and the day after, but not at this conference. So yeah, I'd love to say hi. Also, I brought some stickers that have the same logo, so if you come say hi and ask, you don't even have to ask a question. You can just, or your question can be, may I have a sticker? I'll give you a sticker. So thanks for listening. That's all.